Have you ever really stopped to think about what's happening after you log into a website? I mean, you type in your password just that one time and then boom, you're clicking around from your profile to your messages and the site just knows it's still you. How? What's the secret handshake going on behind the scenes? Well, today we're going to pull back the curtain on that.
It seems like a really simple question, right? But the answer is actually the key to, well, pretty much all of modern web security. See, every single time you click a link after logging in, you're starting a brand new conversation with the website's server. And here's the kicker. The web, by its very nature, has a terrible, terrible memory.
And that brings us to the web's biggest challenge, its memory problem. Every web server is what we call stateless. Now, that's just a fancy way of saying it. It has total amnesia. It treats every single request you send, every click, like it's the very first time it's ever heard from you. Ever.
So think about it from the server's point of view. You send a request saying, "Hey, it's me. Let me see my profile." And the server's response? "Who are you? I've never seen you before. Prove it." Every single time. Imagine having to type your password on every single page you visit. It wouldn't just be annoying, it would be a complete security disaster.
So how do websites get around this amnesia problem? Well, they use two key ideas that work together perfectly, kind of like a top-notch security team. Let's think of them as the gatekeeper and the bouncer.
All right, so first up, you have authentication. That's your gatekeeper. This is the login screen. You show your ID, your email and password, just once to prove you are who you say you are. They check your name on the list and let you in. But then you've got authorization. That's the bouncer who's checking your access inside the club. For every single thing you try to do, the bouncer asks, "Are you allowed to be here? Can you see your own private data?" Yep, you're on the list. Can you try to see someone else's private data? Nope, the bouncer steps in your way. Access denied.
Okay, so the big question is, how does the bouncer know you're allowed to be there? It's not like he's going to ask for your password over and over again. That'd be crazy. No, he's looking for something else, a proof of entry. And that proof is an incredibly clever little piece of tech called a JWT.
A JWT, or JSON Web Token, is basically a digital wristband. Think about it. You go to a festival, you show your ID once at the main gate, and what do? They snap a wristband on you. For the rest of the night, you don't need to pull out your driver's license every time you want to get a drink or enter a different stage. You just flash the wristband. The JWT is exactly that, but for the internet.
So let's pop the hood and see what this digital wristband is made of. It's actually got three distinct parts. First, you've got the header. That's kind of the rule book. It just says what kind of token this is and how it's secured. Then you have the payload. This is the important stuff about you, like your user ID or your email. But, and this is super important, it never contains your password, ever. And finally, the most critical piece of all, the signature. This is a special, tamper-proof seal that the server creates. It locks the header and the payload together using a secret key. If anyone, and I mean anyone, tries to mess with the information in the payload, like changing the user ID to someone else's, that seal instantly breaks. The token becomes completely useless.
All right, so let's put it all together. Let's walk through the entire journey, from the second you hit login to the moment your private data appears on screen. Here's how that digital wristband does all the heavy lifting.
It's basically a 5-step dance. Step 1. You log in with your username and password. The server checks them, says, "Yep, you're good," and creates your unique JWT wristband. Step 2. The server sends that wristband back to your browser, which tucks it away in a safe little spot, usually a cookie. Step 3. Now you click on something. Say, "View my profile." Your browser automatically grabs that wristband and attaches it to the request, without you even knowing. Step 4, and this is the moment of truth, the server receives your request and immediately looks at the wristband's signature. It asks itself, "Is this real? Has anyone messed with it?" And finally, step 5, the signature checks out. The server trusts the token completely, knows it's you, and sends back your profile info. Boom, access granted.
And really, this is the entire genius of the system right here. The server doesn't have to keep this massive, complicated list of every single person who's currently logged in. It doesn't have to remember anything. All it has to do is check the wristband. It performs a quick mathematical check on the signature. If it's valid, it trusts whatever the token says. If it's not valid, the request is immediately thrown out. No questions asked.
So you might be wondering, why go through all this trouble? What makes this digital wristband system so great? Well, it turns out this approach has some massive advantages that are crucial for keeping us all safe online. For starters, it's stateless, which we talked about. The server doesn't need to remember you because the token itself is the proof. That makes things way simpler.
It's also incredibly secure. That digital signature is based on some heavy-duty cryptography, making it nearly impossible to fake or tamper with. Plus, it's super efficient. Verifying a signature is a lightning-fast operation for a server, which means websites stay quick and responsive. And maybe the most important safety feature of all, they're time-limited. These tokens are built to expire. Maybe it's after a couple of hours, or for your banking app, maybe it's only valid for 10 minutes. That means even if a hacker did manage to steal your token, its clock is ticking. It's going to become a useless piece of data very, very soon.
So the next time you log into a website and just effortlessly click around, take a second to appreciate this elegant, invisible dance that's happening to protect you. These digital tokens, these invisible wristbands, they're the silent guardians of our entire digital lives. Which really makes you wonder, right? In a world that's only getting more and more connected, what's next? What will the next version of our digital identity even look like?